Wrong side. Okay, guys, you're gonna go to on a bridge tour. Offers certification even or continuing education. Continuing education. And what you're gonna observe is just a bunch of engineers yakking, having a good time. At some point, if they start talking about something too personal or something that I'm not allowed to record, I'm gonna have to stop the video because they don't want to. We're not supposed to critique in written form. I guess you guys can extrapolate from that. That's gonna be mostly from the hip because I can't really point a damn cell phone at everybody. Let me see if I can get the damn screen up too.
First off, is everybody filled out? Giving me their that keeps you from stealing. Start first with a little safety and then rail program. Precision active construction site. It's not a public walkway, but when we go up those steps, it will be an active construction site. We're going to stay on the pedestrian side of the bridge, separated from the construction traffic, so there shouldn't be that much exposure, but please keep your eyes and ears open and so you don't get ran over, trips, falls, and stuff like that.
This is our version of a safety meeting.
I think we got a couple of stops along the way. It's a narrow path, it's only 14 foot wide, so we got to gather about the speakers so everybody's here and switch from there. Thank you.
Well, thank everybody for coming. We tried something new. We actually have a lunch meeting instead of our dinner meetings, just to see what kind of different outcome we would get. A lot of new faces, so that's a good thing. I want to say thanks to Nick and Ray for putting this together, taking time out of their days, and Bob as well, to talk to us about this project. And then after we're done, we can all convene down at Iron Hill. We'll actually be upstairs in a private room for lunch.
Brian, if I can add on. So if anybody needs PDH evaluation forms, see me if you don't have one. If you need to crumple up, put it in your pocket during the tour, that's fine. I'll take it as is. But if you can try to give it to me at lunch, otherwise scan it and send it in to me.
I'm Ray Petrucci with RKK, and I'll impart some of my historical knowledge when I was with Delgot on the design of this bridge. So all my comments will be other than historical nature of the bridge. We actually already met Nick Hetrick, RKK contractor, and Bob Healy is with RKK, Director of Structures. He's the project director of Structures RKK. So here's the new Christina River Bridge. It's 470 feet from abutment to abutment. Center span is 180 feet. There's two piers in the river. And the back stands are each 145 feet. So there's, on the travel lanes, there's two 11-foot travel lanes, one in each direction, 3 foot on either side for shoulders, and a dedicated 14-foot wide pathway for bikes and pedestrians, and that's basically where we'll be heavily concentrated, say, on the bike path. Because as Nick said, they're running traffic on the other side. The overall width of the bridge is 45 feet. The ADT 10,400 is the ADT. That's the projected numbers with some of the build out of the riverfront areas. This was made possible through, actually about 10 years ago, Senator Carper had an earmark through the federal program, $20 million for startup money for this project. So that's how the project really got started financially. The bid was awarded to Artie Pearson for $28.4 million. The final cost is going to come in about 27, so there was some value engineering in that, so we came in under budget and essentially on time because it's just about completed. Designer record, RKK engineers designed it, AECOM engineers did the review of the bridge, and the owner is Delaware DOT. A little bit about this underpass you're looking at. This was interesting. During the project development, one of the early public workshops we had didn't really show this at all. It showed the Riverwalk, which had already been constructed all the way to the Peterson Wildlife, to stop about this area here and go around and cross over at grade on the new road and then continue. And we had a lot of the public saying, boy, that's going to really mess up our route, and can't you just make a walkway right through the bridge? So the last thing we wanted was a, quote, tunnel, but we said, okay, let's see if we can make the grades work. And we were successful in making the grades work here, having this kind of a structure. You hear about this type of structure in a while. It had to be wide, had to be high. It's 10 foot maximum right at the center, and it had to be well lit. So when you go through here at night, it doesn't even look like you're going through a bad area. You pass right through, you don't even know that there's a bridge on top of it. So we accommodated the public on that. So that's an interesting aspect. Of course, as you see, with the staircase here also, it had to be attractive, had to match, which was some of the architecture that's already here at the riverfront area. Bob, you want to talk about that?
He's a design engineer. I'm sorry, he's Ray's the designer. He's a structural guy.
So technically it would be considered a bridge, and I guess Delta probably will add it to their bridge inventory at some point. We looked at a lot of different alternatives here. We looked at extending the span of the bridge further down.
What he's stating is that that would be considered a bridge too, and I can't see through reflection. But he's stating that would be classified as a bridge, technically.
Here. But few of the crossings not be that difficult. Plans that allowed the contractor to consider precast options, but I probably didn't.
We attempted to try to precast the roof, but had a lot of engineered resistance doing a post-tensioning on a skewed segmental culvert top, and ended up precast.
Yeah, same issue we had in the design. It just couldn't make it work. So it is a cast in place. I call it an arch, so it does have the arch form, but the walls are vertical. One of the really interesting things about this whole
The phone.
because of the geotechnical conditions, there's more material underneath. Some of the things they've done here. The area between the bridge abutment and this first wall of the tunnel is low density concrete.
Oh, low density foam also here.
And then on this side, from here on the back of the road, is styrofoam.
Styrofoam.
All of this was done to kind of lighten the load so that we weren't going to get excessively big foundations. The foundations themselves are kind of unusual in the fact that there were several iterations of the design. We originally designed it for driven piles. precast, pre-stressed square piles. During the course of the design, the department decided they wanted to build caisson, so drilled shafts here. So we redesigned it for drilled shafts. That seemed like that was going to work out okay. When it went into construction, Pearson came back and with a, I don't know if it was called a value engineering proposal or just a redesign.
So when we two contractors bid the job, and we were low bidder, and it was well over the engineer's estimate, and the department asked Kirsten if there's anything we could do to help lower that cost and offer savings back to the department. We looked one of the things we looked at was the foundations. We drive pile for a living. We drive big piles for a living. We have the machinery, we have the hammers, we have the experience. And by taking that scope of work away from the subcontractor that would come out here with some serious access issues and have to install a lot of access, and it would be in a constant struggle with potential changes and issues, we thought that was a good opportunity to offer a credit to the department to take and redesign the foundations ourselves.
There's load testing.
It's
empty.
We brought on our engineer, Harvey Hanover, and I'd say a really good team approach ended up with foundation, or pile foundation.
We ended up back kind of where we started. The disposal of contaminated materials was an issue too, I think.
That too. That's pretty much eliminated all the issues of the contaminated materials.
So the driving of the piles, I mean, we never got a call about any issues. It seemed like it all went according to plan, so it was great. Same thing with all the other kind of unique features of the substructure and the fill. Same thing. It was really unusual to see these big blocks of styrofoam stored out here, and watching how they assembled that. I don't know, was anything tricky about that?
It was very labor intensive. The road doesn't look like it has a skew on it, but there's a slight skew, and the blocks come out like blocks. You can't get them fabricated piece by piece. At least we couldn't find anybody in this cost-effective way. So you have these blocks that came out stair-step, and then we'd have to shape the skew into it, and then also shape the cross-slope of the roadway in, and everything had to be tight and touching, and it went well. It was just extremely labor-intensive. But otherwise than that, it worked well. It went together well.
And that's interesting because when we were first talking about how we would do the approaches, it seemed like the styrofoam construction was, the labor was going to be a lot less, so we were going to get a better product. Now, curiously, we had some lessons learned because, as Vic said, it didn't turn out that way.
We were actually approached at some point by a vendor who takes recycled glass and heats it up and blows it and makes lightweight aggregate that we use in Europe. And they wanted to try to do that trial job here. Unfortunately, the timing and cost didn't work for us, and I think at that point the department was done. I can only push so much further for new things in this job. It'd be something to keep in your mind. It would be basically building an MSE wall with a lightweight aggregate as opposed to styrofoam blocks. So a lot of labor savings there, but the material cost was up.
Yeah. On the design side, we had a lot of discussion between the department and the econ staff about the design aspects of that lightweight fill there too. We didn't always see eye to eye. So it was an interesting design problem. Great. You say at one time the bridge was not quite as skewed as it is now. The bridge is going to cross right about where we're all standing.
Yes, there were actually the original plans which just go straight on across.
So there's skewed means not square to this part of the property, if you will. It reached me some 90 degree. But I'm going to tell you the story of
on 90 degrees and
the Coast Guard, or how it is.
So, curiously, the land where the East Abundant is right now was owned by the RDC, and the RDC gave DelDOT that tract of land. So what happens, we were going to have to build that bridge on it.
I'll pass on that Coast Guard thing.
$9 million. And realization of all those people at James Court. So actually, when you say you have $1 million in paintings, it actually goes on top of that, because we were granted that Jablo property as kind of like
That was reference to height.
to the cinema deal, which is
And it's these guys that had to be parallel with
so
the
we worked out.
piers had to be parallel.
Well, here we're gonna eat up our same place here, but when we did the analysis, correct me, Bob, is that it wasn't that much more.
Yeah, it's a slightly longer bridge instead of 90-degree crossing would be, of course, but in the end, it wasn't that big of a deal. The reason we moved it from, like I said, we were crossing the battle angle previously at one time. It ended up being very close to the stop here.
Oh, the shops are behind us, guys.
Together, and then we loaded that prom ride.
I don't know if you guys can hear me. You have to comment if you can or not, if you can hear them.
Probably a good time because you can see it better. The bridge itself is a bridge. In and of itself is not unusual. But the design is kind of special, and I think it's unique to Delaware. It's probably the first time Delaware has built a bridge such as this. It's a three-span continuous bridge, but it's not continuous in the way that concrete bridge is normally done. Usually you direct girders as simple spans, 1, 2, 3, and connect them with diaphragms to make it continuous. It's only continuous for live load. In this case, because of some of the aspects of the design, they wanted to keep a low profile on the bridge while still achieving the required underclearance. And so we were kind of left with a narrow window to try to squeeze a girder through. Originally we had a steel girder bridge design here, and DelDOT decided they preferred concrete just for future maintenance and durability. And so the solution was what you're seeing in front of me, which is a slate concrete bridge. So it's made up of 5 segments. You can see the 2 segments over the pier that has a horn, the main span segment and then the 2 end span segments.
Enclosures.
And the erection of those elements is really what makes this kind of unique and very critical. It's not as simple as just dropping the beam in and letting it.
Enclosures where you see the like the stain type system, concrete for you guys.
Across, waiting for the adjacent beams to come in. You do the end spans back, so they're kind of connected.
And the 5 he's talking about, we'll see from underneath when we get to it. You can see here, let me see. Let me count underneath, 1, 2, 3, 4, 5.
So the bridge is now 5 segments all kind of put together and held temporarily together. And then you cast the closure towards. And after those,
these are the closures we just talked about.
These are continuous, but they have to be jacked together.
Post tension is going to pull it together.
Challenges with that.
You did a really good job explaining the whole process. Saved my throat a lot, so I appreciate that. The first challenge was, how do you temporarily support the center girders? The engineer had a pretty good structure system mounting to the actual pier wall. We had just finished a job down at the Jersey Shore. This bridge was sort of like a miniature of what we just finished. So down there we used like a backspan support system where 15 or 20 feet this side of each pier, land side of each pier, we drove some pipe pile in, put a header across the top, and cinched those girders down onto that to make a more rigid structure. And that allowed us to finish the architectural treatments on the pier cap itself, or the pier stump itself. Plus we had that material on hand, and some engineering behind it as well. So that helped us accelerate some of the work there. But that was the first challenge. The second, of course, is the strong backs, which fortunately we had that in our yard too, so we just finishing the job. And then splicing everything together, the high-strength concrete we used to get some strength gains for schedule on that, and then the post-tensioning. And pretty much what Bob said, it went pretty much the plan.
Yeah, I really liked your temporary span and the temporary support in the back span. We had conceived temporary supports coming up off the pier, which I didn't like as much. And you far as that, I thought that was a great idea. Give them a lot more stability. What else? The deck itself is just the conventional concrete bridge deck with reinforcing. You'll see the railings up top. We can talk more about that when we get up top. And of course, you know, being located where it is, everyone's concerned about appearance on the bridge. So we put a lot of effort the bridge is lit at night, has a nice little kind of a ribbon effect to it. I haven't seen it myself with my own eyes. I'm looking forward to it. I hope it turns out like everybody envisioned it. Ray, what's the reaction been?
They can't wait for the bridge to be open. They're so glad. The community at large was so glad when this stretch was opened up. Here in the summertime, there's always activities. There's always runs of all kinds, and this is one of their major areas. So now we'll go up the golden staircase. So we'll come.
You notice in the tunnel there's cranes along 4 of them. They're lit. They're
Public art.
future home of public art.
Yes, that was another thing we wanted. We wanted to be able to at least have it accommodated for future public art, and the city and other agencies can get together and do that, whatever they decide. But that'll be very attractive in the future. So we'll go up the steps, and right at the top of the staircase, we'll discuss more. And if you have questions for us,
Here we go. Here we go. Here we go. Cattle. Cattle.
there we go.
Attention.
She didn't make mistakes.
Chattel, chattel. Okay. Looking good, right? Good.
You're always prepared.
Yeah, fair.
We often get questions about the location of the bridge. Actually, originally about 20 years ago, we planned for the location of the bridge further down, a little further south of here.
That's a rarity.
This
Catch the
area,
train going
you
across.
see Pearson's yard here in their lay down area. That was supposed to be more shipyard shops. But when the shipyard shops kind of didn't turn out the way that everybody thought they would, they changed the name to Shipyard Center. They expanding this, so this allowed for the bridge to come up in this particular area here. You see the railroad bridge still being used by Norfolk Southern once or twice a week, and this is one of the times we ask them to show the people how it's really an active bridge, and they're perfect. So that's actually a swing bridge. It was designed and constructed as a swing bridge for navigation, but it has been welded shut, and for all our research, it's been that way for 40, 50 years. So that wasn't going to move. And that really directed us, and as far as the vertical clearances here, we knew that a Cab-on nickel, for instance, a tall ship, couldn't go that far, couldn't go any further down on the Christina River. So, anything on the design more?
Yeah, so the Christina River is considered navigable by the Coast Guard. So obviously we had to get consultation with them to get a permit. I think they came back and required 12 feet of clearance, which DelDOT, I think, added 2 feet to account for future sea level rise. And so the clearance here is 14 feet through the main span. As Ray said, you don't get much navigation up here of any kind. A lot of
Recreational.
yeah, recreational. I don't know, do they still have rowing down here?
A lot of rowing.
Yeah.
A lot of rowing.
So that nobody really has any trouble getting up here. There's really no reason to go much further. Quick word about the staircase that just came up. Structurally, it's not really much of a thing. It's just kind of a couple of retaining walls with fill between them. The difficult thing is the geometry. I'm sure Nick can tell you about the difficulties in laying that out and then constructing it and then getting the railings to fit.
So we'll start there, and I think maybe I'll hit a couple other construction things here. So yeah, the curve radius, so we used EFCO ready radius forms, which really helped getting the curve, but getting the right elevation from the steps took some significant survey layout and number crunching. Our railing manufacturer was challenged to manufacture the railing. In fact, we're still waiting for the actual handrail to get here. It should be here next week, about 6 months behind schedule. We've got some corrective work to do. You know, if you notice some railing pieces missing. Multiple as-built, multiple revisions on shop drawings, and it's still a challenge. But it's a centerpiece, and we want to make sure it looks right. This is where all the photos are. The railing that's going to come, the linear, the actual will have LED lighting in it, and that's going to provide lighting for the staircase. It should look really nice when it's done, and landscaping in the front. The pile foundations that the bridge is sitting on, we did a 90 foot long, 24 inch by 24 inch square pile for the abutments, the wing walls, the staircase, the underpass walls, and then the piers are sitting on 100 foot long, 30 inch by 30 inch square piles. We put a 5 foot stinger, H-pile stinger on the bottom. When we did the design process, there was a lot of concerns with the Potomac that underlies here being too stiff, and when that big fat pile hits it, it's just going to sit there and bounce and bounce and bounce and not be able to get itself through, or any of the other cobble and things that we encounter in this area. So with the 5 foot stinger, we used a barge mounted Manawak 4100 Ringer crane, basically serviced the whole job, and a D160 hammer to do the 30 by 30s. Us and Wagman, I think, are the only two on this side of the country, and it's the hammer you need to do this work. We use the I-80 on the 24 by 24s. And there was a lot of concern from the, we brought in Kazera, a local Mid-Atlantic expert on pile driving, for some input from them. And there's some concerns about the clay layer and what we'd encounter. And we went around a bunch of iterations whether we should do some probing to try to break it loose. Even came back to doing some augers, and so we know what, we're going to drive some test piles, see what it does with our per plan, and that went well, so we committed to it. I think we got approval to start the design process in June of 2017. We awarded the contract in May of 2017. June of 2017, we got approval to move forward with the design process, which I think the biggest delay to get there was more internal at DelDOT saying no contractor's ever gone down this route, and how can we have two engineers owning one bridge? So, but we all got through that. We had shop drawings approved by July, and we had an internal goal of driving pile by Labor Day, and we had approved shop drawings by the end of July, and unfortunately some material procurement for some epoxy coated strand pushed the pile production to probably mid to late September before we could start driving pile. But I said it once, and I say it at all my walking tours here, that if it wasn't for RK&K's cooperation, the DelDOT's cooperation, and I think it was a really good team approach, and it should show what we could do as contractors and engineers and owners to have some successful projects. And it went smooth to think. Because when we rechanged the foundations, it also changed the footing sizes. It's not like we were cramming the same piles under the same footprints. The footings doubled in size, and there was involved some re-engineering of the footings, issues of plans and stuff, and it went very well. We did hit a lot of ground. This whole area over here was old industrial site, and it looks nice and pretty and capped off there, but 4 feet in the ground. every 10 feet there's an old pile foundation from the building that used to be here, the shipbuilding and the other activities back in the day. So we had to fight through that, but for the most part, really well around.
Heading up to the midspan. I think I'll ask my man Ray about these W's. He designed them freehand. He might be proud to speak on that. Yeah. Questions. Hey Ray, who designed these W's?
I have no idea.
I'm going to mention that in a second. So
Yeah. Yeah.
That case on?
Yeah, originally the caissons I think were supposed to go 10 feet into the rock or so. I was curious. I think we could have done it. It would have came with a lot of challenges and change orders.
You might not like this
You
question.
know
What's
the
with
drill
the
itself.
cracks
Yeah.
right below the couple of sections here? I keep seeing repeated cracks on the outer wall. Repeating. Oh, never mind. I don't see anything. I apologize.
Yeah, at center span, now Bob had mentioned the vertical clearance 14 feet. The channel is 150 feet, the navigable channel. And when this was said, as far as the location of the bridge, we realized that we needed the connections. On the west side, we needed to improve all the roadways, and that's what R.E. Pearson's doing now. They also, on a separate contract, is awarded the approaches roads, and that's what you see. The extension of South Madison Street, coming from all the way on the other side of where MLK is, and Madison Street will extend all the way down. And also Justison Street was our first spine into the riverfront. And on the other side, the extension of this road, which was called New Sweden Street, and I think we're going to call it Peterson Drive, will go all the way to Beach Street. The biggest problem here 20 years ago, you had one way in. First of all, you had nothing here. They had just built the stadium, but you had one way in and the same way out. So it was important to get the crossing of the river, because what happens here is the end of this, at the end of the bridge, you access US 13 and you access I-495 and 95. If you've ever been to a Blue Rocks game and you're from the south, you know to leave, it's like a parking lot, and you have to go north to go south. Well, this will split up the traffic and solve those traffic concerns. And one of the things, well, there are two questions I've always gotten, or comments through the years. You'll never build that bridge. Especially when I saw Senator Carper in the crowd and he recognized me. You're going to build that bridge, aren't you? You're going to build that bridge. The other thing was the hotel. This area will never have a hotel. As you can see, the West End is here. These two new hotels just opened up, the Open Suites
Brandy,
and
you're
the
right.
Hyatt House.
I gotta
So
be
now
good
there are
though.
3 hotels.
I signed a paper beforehand. We all signed one.
And I hope it carries over to the other side of the river.
Yes, and that's the other thing. Not only the transportation element of the bridge, but it opens up the entire development on the other side. It's already started. Dollars are already earmarked for that side of the river that will actually start early next year. So now we're going to go to the East Department. Anything else? Go ahead.
I have a couple quick things to point out. to look at this, I grew up in Wilmington. In fact, if you look up the hill there, that's one church way up on the hill, that's my family's parish, St. Elizabeth. The sea just down here on the waterfront. When I was a kid, you know, this is a place your parents told you don't go anywhere near this. You know, it's an industrial site and it just becomes nothing. To see how this has developed in the last 20 years or so has been quite amazing. So when they were proposing this bridge, one of the goals was to try to low profile, flat, and I think we were able to do that. You know, we didn't want to see grade going up to get up over the river, and so I think it's very user friendly for, especially for this path. The other thing that they wanted was to kind of preserve the views of the river, upriver, downriver, skyline. Set up from Wilmington. I know this is not Manhattan, you know, the skyline, but you know, it is what it is. So the choice of these railings came into play. You know, they wanted to keep it kind of open and visible, not just solid concrete barriers that you can't see through. And so I think they were able to achieve that. These barriers on the roadway side are actually Virginia DOT standard details that we like. They're also used down on the Indian River Inlet. This one here is, again, made to keep open. Somebody asked about the W. I don't know how many different fonts of W we looked at to put here. The key thing about it has to be symmetrical because you can see it from either side. And so I think there was a couple of examples around town of W's put on some highways or bridges, and so we ended up choosing this one. Kind of like it. Nick?
A couple other challenges, of course, marine access, how to build a bridge on a river with actual real no access to it. So we constructed a five-span trestle, which is a fancy word for temporary dock. That got us from the land across the river walk, that was detoured, and far enough out to the Christina River in the deep water. At that point we floated in our 100 by 100 foot barge with our crane on it, a material barge, a 40 by 100 material barge, a couple tugboats, and we were able to set up a marine shop here. And all our material came out on our trestle. We picked it with our crane that's on the barge, set it on our material barge, used our tugboats to push us around, float us in the spot. And that's how we constructed the bridge. Started with coffer cells for the piers. The design had these big precast tubs. It was a great idea.
Look at the bolts, how they put the bolts on this side where the pedestrian walks.
Cheaper way to
The
go.
bolt
We just
heads.
went ahead and drilled coffer cells.
I'm sorry,
down
not the
middle
bolt
of
heads,
river
the
and
back of the
watered
shank
down to below the pier cap elevation.
and the nut.
From then we could set our pile frames on top of that, stick 14 of our concrete piles in at a time, and then pick the hammer up and knock them all down in one setting. And then came up with some false floors, sacrificial false floors, and came on up. We also did a value engineering with the department and eliminated, originally there was a granite fascia around the pier caps. We had concerns and long-term maintenance issues with that durability, and we're able to offer the department a savings by just going to a form liner system that was stained. We actually brought the mayor and the head of the RDC out on a boat down into the coffer cell on some floating planks to verify that that's the color that they wanted before we pulled the sheets. So that just carried all the way, that aesthetics carried all the way through the job. The mayor and RDC was, they picked the colors, they picked the form liner, and it just kind of set the tone for the rest of the job. Same thing for the bridge girders, backed them out one by one, loaded them on our barge, one span full at a time, floated out, set a span, went back and picked it up and went from there.
Any questions?
The mayor's not just a color finder, he's actually a builder connected to this whole entire build down here. This entire huge, you know, tens of millions of dollars worth of build. He was in it years before. He just became the mayor. I guess because he wanted to become the mayor. So he's not just a color finder. He's actually pretty big in contracting. Oh, he is. I don't know what his interest would be here. Of course, he'd have some, but it's still positive all the way around for the environment. You know what I like to say, the culture, the dialect. Here's the W that's uniform. And that was Ray's credit. You get to leave your mark. And you guys notice the 2-foot water level that they believe is going to happen, that they planned for. There's your expansion joints. Over on the other side is the 76ers. Right there. There and here now. This thing is just huge. This whole project. 76ers right in the background. It's a huge stadium.
Behind me is James Schwartz. They talked about earlier. You can see everybody's going visit, and they're happy. As you go towards the end of the approach, you can see the new 76ers field house, which was just opened earlier this year. And the road, this Peterson Drive, will go straight across on the US 13 intersection, make a major intersection. That's what they're working on now. And there are some challenges there because there are utilities and there are all kinds of lane shifts and movement to contractors to do to get that in.
The 76ers.
We knew that was going to be a major challenge to this, and that's the only way for this to work out. During the course of the design and the planning for
The
the plant,
76ers do come there too, but it's got a multi-bunch of functions.
Land on the other side. And that's what you see, the sports complex.
So that truck was loaded, just came by. Felt no vibration
So
over here.
what happened is we were able to have a nice, smooth transition onto the other side, which will also be developed. And that presents also some good connections to the neighborhoods on the other side, the Southport Ridge neighborhoods on the other side of the river. So as you can see, if you look in this direction north, you'll see the future development here, which I mentioned earlier, which will be happening. Planning for it is already started. Next year, you'll see some buildings in this area.
Just quick thing about the on this side is